Hello guys, welcome back to my channel. Today we are going to talk about the ARP protocol, which is also called as Address Resolution Protocol. So before we talk about the ARP protocol, let's talk about what protocol is. What is a protocol? So a protocol is basically a set of rules or a set of standards that has been predefined and that has been agreed upon by all the vendors making these routers and switches or any networking devices, that this is how this particular protocol will function. So right now we have a lot of routers and switches in the internet, right? So all of them have to follow at least certain rules to behave in a certain way, which by which routing, forwarding, packet switching, all of this take place. So like this, we have many such protocols which are running on the internet, and these protocols govern how the internet works. So such protocol, such the R protocol is one of these protocols. It's basically a layer 2 protocol. Uh, to understand our protocol, let me also tell you about the MAC address, right? So the media access control layer control. So MAC address is basically a hardware address. It is a unique identifier of every device. It is pre-configured. It cannot be changed. It is unique throughout the world. Every device has its own MAC address. Okay, so this is basically address which is part of the L2 header, and it will be used to identify which device the packet has to be forwarded to within the same LAN or within the same network. This will not be used for routing of a packet. It's only used when we want to determine which hardware it has to go to in the same network. And we'll see more about this when we talk about the ARP protocol. So the ARP protocol or the address resolution protocol is a communication protocol which is used for discovering the MAC address associated with a given IP. So we know the IP address, but we do not know the MAC address. So this protocol can be used to determine what MAC address is associated to a particular IP. It can be also used to determine what IP is associated with the MAC address. Uh, that's called reverse ARP. So there are different types of ARPs, reverse ARP, proxy ARP, gratuitous ARP. So these are the extensions of ARP. You can probably go through it, but I'll teach you like how the basic ARP works. So I've taken this particular example over here. So I have, you can see over here that I have the host A, I have host B, I have a router A, I have a switch A, I have host B. So host A, host B, switch A, router A, and host D. All host A, host B, switch A, and router A are part of 11.11.10.11.11.0/24 network. Okay, this is my network IP. So all my devices in this network, like host A has the IP address of 11.11.11.10, host B has IP address of 11.11.11.20, and the router A has IP of 11.11.11.1. Okay. Now the switch A is a layer 2 device, as I mentioned before. Its job is to forward the packet out of the correct interface. Okay. Now we'll have also defined the MAC address over here, which is not user configured. It is unique to each device, and this is already pre-configured. It comes. So it's a 48-bit number. I'm just gonna use the last two digits to determine the MAC address. Okay. So host A's MAC address is AA, host B's MAC address is BB, and the MAC address of the router A is EE. Okay. And I have another host D, which is part of a different network, which is part of, let's say, 22.22.22.0/24 network. Okay. Now I want host A to talk to host D. Host A wants to send a message to host D. Okay. And now you can see that I also have the ARP table over here, the routing table, host A's routing table. I have switch A's MAC address table. I have router A's ARP table. All of these tables are empty right now. Okay. Now what will the host A do? Host A wants to send some information or some message to host D. It will create the data. Okay. Pass it down to the L3 layer. L3 layer will have its own source destination, right? So it knows its own IP. Host A knows its own IP. Host A knows the destination IP of host D. So it can create the L3 header also. Okay, but for the L2 header, it knows its own source MAC address. It knows. Okay, so but it does not know the destination MAC address. So destination MAC address would be what? Destination MAC address would be the MAC address of the router A, because that is the gateway. That is the gateway of this network. The router A is nothing but the gateway of this network. So whenever we use the L2 header, right, the destination MAC will be the immediate next hop address. Okay, whereas the L3 destination IP would be the end destination IP. Okay, now host A will check its ARP table to see if it has a destination destination MAC address. But as we see, there is no destination MAC address over here. Okay, so what do we do now? So we use the address resolution protocol to determine the MAC address of the router A. Okay, now the host A will send a ARP request. Okay, the host A will send the ARP request. The switch A will receive the ARP request on interface 1. Okay, so what will the switch A do? The switch A will check its MAC address table. Switch A does not have an entry for the packet which has received from host A. So what it will do, it will populate its table. It will say that on interface 1 I have received a packet with the MAC address of AA. Okay, then it does not know which interface it has to send it out from. So what it will do is switch A will flood the packet to all the other interfaces except the interface it has received the packet from. Now the packet is sent on the second interface to host B. Host B will see the destination IP, and destination IP is not its IP, so it will just discard that particular packet. Now the host router A will see that receive the packet, and it will see that the destination IP its own IP, so it knows that the packet is intended for router A. So it will keep the packet, and the router A will see that the packet is received from host A. Okay, so what it will do is it will see that the entry is not present in the ARP table, so it will populate its ARP table. So the ARP table will have the entry of 11.10 has the MAC address of AA. Okay, now what will the router A do? Router A will send out a ARP reply. Now router A knows the destination IP of, which is the .10 IP, which is the .10 IP of host A. It knows the MAC address also of host A. It knows its own MAC address, which is EE. It knows its own IP also. So we know the source IP, we know destination IP, we know source MAC, and we know destination MAC, and that is sent out on interface and to the switch A. Now switch A will receive the packet on third interface, right? So it will see that entry is not there on switch A's MAC address table, so it will populate its MAC address table, saying that on interface 3 it has received the packet with the MAC address of EE. Okay, and then it will check the packet's destination MAC address, which is MAC address AA, and it knows that this packet has to go out of interface 1 as it has already been populated in its MAC address table. So switch A will send the MAC address, will send the ARP reply out on the interface 1 only this time, and it will be received by the host A. Host A will see that the MAC address for the IP 11.11.11.1 is EE, and it will populate its own routing ARP table as well. And now it will populate the L2 header which it was supposed to populate. Now that it knows the next hop's MAC address. Also host A will populate its, so what happens is whenever we configure the interface, right, with an IP address, the device will populate its routing table automatically. Okay, because it is a directly connected interface. So it knows that 11.11.11.0/24 network can be reached via interface of host A. Okay, so this is how the ARP resolution protocol is used to determine what is the MAC address of a given device based on its destination IP. Okay, so it is mapping the IP to the MAC address table. Okay, sorry, mapping the IP to MAC address. Also, it can be used to map MAC address to IP, IP to MAC address. You can just read about it, reverse ARP. You can read about the proxy ARP. So all this, but this is how the major chunk of the functionality works. Okay, this is how the functionality works. ARP request is sent, ARP reply is received. You get to know what are the ARPs configured on the devices. That is the MAC address. So ARP is used to link the IP to the MAC address. So tomorrow we are going to talk about how the packet further traverses, routes and reaches host D. Again, what happens in the other network. So that will complete our entire packet traversing through the networks, through different networks. I hope this helped you understand the MAC address concept and the ARP protocol. Please do like, share and subscribe guys, and let me know in comments if you have any questions. Thank you.